Lenses are optical devices that refract light to produce images, and they come in two main types: convex and concave. Each type of lens affects light in different ways, resulting in distinct kinds of images. Convex lenses, also known as converging lenses, are thicker in the middle than at the edges. When light rays pass through a convex lens, they are bent inward toward a focal point on the other side of the lens. This ability to converge light allows convex lenses to produce images that can be either real or virtual, depending on the position of the object relative to the focal point. For instance, when an object is placed outside the focal length of a convex lens, the lens produces a real, inverted image that can be projected onto a screen. If the object is within the focal length, the lens produces a virtual, upright image that appears to be on the same side of the lens as the object. The behavior of light through a convex lens follows three key rules for refraction. First, a light ray that travels parallel to the principal axis, the central line that runs through the center of the lens, will refract through the lens and pass through the focal point on the opposite side. Second, a light ray that passes through the center of the lens will continue in a straight line, without bending. Third, a light ray that passes through the focal point before entering the lens will refract and travel parallel to the principal axis on the other side. These rules help determine the path of light through the lens and allow for the construction of accurate ray diagrams, which are used to predict the position and nature of the image formed by the lens. Concave lenses, also known as diverging lenses, are thinner in the middle and thicker at the edges. When light rays pass through a concave lens, they are spread out or diverged, making the rays appear to originate from a single point on the same side of the lens as the light source. Due to this divergence, concave lenses always produce virtual, upright, and reduced images, meaning that the image appears smaller and cannot be projected onto a screen. These lenses are often used in devices like eyeglasses for people with myopia, nearsightedness, where they help to diverge light before it enters the eye, enabling clearer vision of distant objects. The refraction of light through a concave lens also follows three specific rules. First, a light ray that travels parallel to the principal axis will diverge after passing through the lens and appear to originate from the focal point on the same side as the object. Second, a light ray that travels directly toward the focal point on the opposite side of the lens before reaching it will emerge from the lens parallel to the principal axis. Third, similar to the convex lens, a light ray passing through the center of a concave lens will continue in a straight line without changing direction. These rules describe how light interacts with concave lenses and are essential for constructing ray diagrams that show how virtual images are formed. In summary, lenses manipulate light to form images, with convex lenses converging light to produce either real or virtual images, and concave lenses diverging light to produce only virtual images. The refraction of light through both types of lenses follows specific rules that determine the path of light rays and the characteristics of the images they produce. Understanding these principles is fundamental to the study of optics and the design of various optical instruments.